In this video, I'm going to find the center of mass of a lamina bounded by the functions y equals x to the 2/3, y equals x squared minus x, and the line x equals 0. So there's a lot of formulas for doing this. First of all, let's write down some of the formulas. First, we need to find the total mass, m, small m, and that's equal to the density times the integral from a to b of f of x minus g of x dx. That gives us the total mass. The other thing that we need to know is capital M sub x. Okay, so this is the center of moment about the x-axis. And that is also equal to rho times the integral from a to b. And that is going to be 1/2 times f of x squared minus g of x squared dx. And the third formula we need is the center of mass about the y-axis, or I'm saying the moment about the y-axis, and that is rho times the integral from a to b of x times f of x minus g of x. So I'm just going to write those down to get them out there so we can come back to them. So the next thing we want to do is to create a diagram. So at this point in time, of course, I went to Desmos. And in Desmos, we get something that looks like this. So y equals x to the 2/3 is in red, and y equals x squared minus x is in blue. And so the line x equals 0 is basically the y-axis. So that means our bounds of integration are going to be from 0 on the x-axis to this point over here, 1.8192. So that's going to be our bounds of integration from 0 to 1.819. I'm just going to take it out 3 places. All right, and so then I'm also just going to create a little sketch so I kind of know what I'm looking at here when I do this. So we have this function that's going up like that, and another function that's kind of going like that. And so this point right here, and this point right here. And so we are looking for the center of this region right there. And so the top function here is going to be the function x to the 2/3. And the bottom function down here is x squared minus x. We need to know which one is on top and which one is on the bottom. And they do not cross in this area between x equals 0 and x equals 1.819. They don't cross. So that just means that this is going to be my f of x, and this is going to be my g of x in all of these formulas. Okay, so let's start off by finding the total mass. And so the total mass of this, m, is equal to rho times the integral from 0 to 1.819 of x to the 2/3 power minus x squared minus x dx. And now let's just kind of simplify that a little bit. Rho from 0 to 1.819 x to the 2/3 minus x squared plus x dx. And now we can integrate. So we have m is equal to rho times x to the 2/3 raised to the 1 power would be 3/3. That's 5/3. So 3/5 x to the 5/3 power minus 1/3 x cubed plus 1/2 x squared. And that's being evaluated from 0 to 1.819. Now, there's no way I'm actually going through and evaluating all of this at 1.819. So this is when I went back to Desmos. And so I entered this function as the function g of x. It was just random. I just chose g of x to be 3/5 x to the 5/3 minus 1/3 x cubed plus 1/2 x squared. So I entered the function as a function of x, and then I said small case m is equal to g of 1.819 minus g of 0. So this is where I actually evaluate. So you enter the function in Desmos, and then you evaluate the function, let Desmos do all the work. And so m ends up being 1.2744. So m is equal to 1.2744. I don't even really need to write this down here because I'm going to let Desmos do pretty much all of the work here. So again, what I have done is I have taken this and entered it, actually that, in, we don't need the row. We know that that's going to cancel out in the final formula anyway. So let this be equal to g of x in Desmos, and letting Desmos do the work from there. All right, the next thing that we need to do is find m sub, I guess I found m sub x next. So that's rho times the integral from 0, 1.819. And so this function is going to be 1/2 times f of x squared, which is x to the 2/3 squared minus x squared minus x squared dx. Okay, so that 1/2 is being multiplied by all of that. But actually, I'm going to pull the 1/2 out. So m sub x is equal to 1/2 rho, the integral from 0 to 1.819. And so x to the 2/3 squared is x to the 4/3. And then squaring x squared minus x, we have x to the 4th minus x cubed minus another x cubed, so minus 2x cubed plus x squared dx. And one more little step in here, m sub x is 1/2 rho times the integral from 0 to 1.819 of x to the 4/3 minus x to the 4th plus 2x cubed minus x squared dx. All right, now integrating this. So m sub x is 1/2 rho times x to the 4/3 plus 3/3 is 7/3, so 3/7. We're going to have just 3/7 x to the 7/3 minus 1/5 x to the 5th plus 2x to the 4th divided by 4 is 1/2 x to the 4th minus 1/3 x cubed, evaluated from 1.819 to 0. I can't fit that in there. But, and now I can multiply through by I'm going to multiply through by this 2, just to take care of that. So we're going to have 3/14 x to the 7/3 minus 1/10 x to the 5th plus 1/4 x to the 4th minus 1/6 x cubed. And that's being evaluated from 1.819 to 0. And again, and the row we don't really need to worry about. So again, I'm going to take this and I put it into Desmos. And I believe in Desmos, I called it f of x. Yeah, f of x is 3/14 x to the 7/3 minus 1/10 x to the 5th plus 1/4 x to the fourth minus 1/6 x cubed. That's my function f of x. And then I evaluated function f of capital M of x, the center of moment, or about the x-axis, is f of 1.819 minus f of 0. And so m sub x is 0.607. 0.607. 0.607. And we are not done yet. We now need to find m sub y. And m sub y is going to be equal to the integral from 0 to 1.819 times x times f of x, which is x to the 2/3, minus x squared minus the x squared plus x. I'm just going to distribute the minus through there, dx. So m sub y is equal to the integral from 1.819 to 0. Okay, so multiplying this, x to the first is x to the 3/3 plus 2/3 is 5/3. X to the 5/3 minus x cubed plus x squared dx. Okay, and so now we can evaluate that integral, m sub y. And of course, oh, I forgot there's a row out here. And so we have rho times x to the 5/3 plus 3/3 is 8/3. So we have 3/8 x to the 8/3 minus x to the fourth, 1/4 x to the fourth. And that would be plus 1/3 x cubed from 1.819 to 0. And I am going to take all of this and I am going to plug it into Desmos. And I call that h of x. So that's h of x, 3/8 x to the 8/3 minus 1/4 x to the fourth plus 1/3 x cubed. And I evaluated h of x from h of 1.819 minus h of 0, and I called that capital M sub y, the center of moment about the y-axis. And so that is in 1.118. 1.118. 1.118. Is that what it was? Yeah. And so we now know that our x value, x is equal to m sub y over little m, and y is capital M sub x over m. And so m sub y is the 1.118. And I have to go back and look at what my other numbers were. We had m sub x is 0.607. 0.607. This would be y. This would be x. And then little m was 1.2744. 1.2744. 1.274. And this is all completely redundant because I'm not actually using this to calculate it. I'm just doing this to say, yeah, this is how we actually do it, but I'm going to let Desmos actually do all this. And so back to Desmos, the last steps down here, we can say I let x be equal to m sub y over little m. Y is m sub x over little m. And so x is equal to 0.877 and y is equal to 0.477. Now, when you let x be equal to m sub y over m, you are actually creating a line of the form x equals b. And so you learn in a basic algebra class that a line of the form x equals b is a vertical line. So what we just created by m sub y over m is we've created a vertical line. And that vertical line is in purple on the graph. And then y is equal to m sub x over m is a horizontal line of the form y equals a. And so that is the black line, that is the black horizontal line. And so where those two lines cross is our point of intersection of those two lines. That's our point. So the point right there is 0.8773, which is the x value, and 0.477, which is the y value of the center of mass. And so in a problem like this, let Desmos do all the heavy lifting, but you need to know how to set up the integrals. You need to know how to actually do the integrating. And so that's that. So hope you enjoyed this video.